Hi, everyone. Welcome to our bi-monthly spinal cord injury in service. This month, Dr. John Lasko will be discussing sports wheelchairs and performance. I think this is a really interesting topic that a lot of clinicians probably don't know a ton about. So with that, John, take it away.
Yep. So as Dr. Abramoff said, it's going to be about sport, adaptive wheelchairs, and performance. Equipment and performance is something that's pretty ubiquitous in sports. Like if anyone golfs with golf clubs, tennis rackets, tennis shoes, F1 racing, everyone knows like the equipment is a very important part of performance. And, in wheelchair sports, obviously, it's not something maybe I thought about until I got into PM&R, but a wheelchair in wheelchair sports is going to be a very important part of performance. This is just screenshots I took of the T53 100-meter wheelchair race from the Paris Paralympics. And I just did this to reference at how small the difference is between first, second, third. It's like tenths and hundredths of a second. And so in every little inch and second matters, the wheelchair and how it's configured is going to matter. So just like very, very basic wheelchair information. There's the wheels, there's a large drive wheel, which is the main wheel, and then there's caster wheels, which are small wheels in the front that allow for steering and maneuvering. There's anti-tippers that we can put in the back of the wheelchair. Tires can be pneumatic or solid rubber. The camber angles, which we'll talk about more, is the angle of the wheel in relation to the wheelchair. Wheel axle position can be posterior, anterior. Posterior is, more stability, harder to propel though, and anterior is less stability, but easier and more efficient to propel. The push rim is used to propel the device. A larger diameter push rim improves torque, and there's less force needed to move, which we'll talk about more as well. The seat, many things are adjusted. The height, the cushion, the angle of the seat are just a few things. And then the footrest, the position of that can impact the center of gravity for the wheelchair. So the history of sports wheelchairs, very briefly, organized wheelchair sports started sometime in the 1940s with wheelchair basketball. At that time, as you can see in that top right picture, most just used their standard wheelchairs they were given. Until the 1980s, really, most wheelchair athletes just used their everyday manual wheelchair, but they started to make their own minor modifications for performance. Things like removing the armrest, adjusting the backrest and footrest, increasing camber on their own, and changing wheel size. But starting in the early 1980s, the rules started to change as athletes were adamant alterations in the wheelchair configuration would improve their performance and also would promote safety and prevent injury. So the principles of design for sports wheelchairs, kind of obvious in a way, but you want to minimize weight while maintaining stiffness and sturdiness. You want to minimize the rolling resistance. You want to minimize injury risk, clearly, and you want to optimize the fit to the user. It's not a one-size-fits-all for every sport, every position in every sport, and every user. And, many of the principles that started in sports wheelchairs are now being passed down to everyday use wheelchairs. So it's good for really all of us to know, even if you're not, specializing in adaptive sports wheelchairs. So this is the one study I was looking at, they basically were there's one paper was saying like things we look for is you want it to be light but strong. Obviously, they've been taking a lot of research from aerospace fields, using things like aluminum, carbon fiber, Kevlar, fiberglass. Lighter wheelchairs are obviously easier to move, and adding more accessories improves stability, but it will add weight to the wheelchair. And you want to use high pressure, low resistance tires. So I have some primary literature in here just to show that this stuff is actively being researched in the field of adaptive and wheelchair sports. This is from 2018, and they used 20 elite wheelchair athletes with 10 with low spinal cord, 10 with high spinal cord level of injury. And I guess this isn't too surprising, but they found that wheelchair mobility performance was significantly sensitive to adding more weight to the wheelchair. So with more weight, there was reduced average acceleration, reduced maximal rotation, and rotational acceleration. So that was studied actually scientifically. Wheelchair propulsion, this is just basics. With any wheelchair propulsion, there's obviously upper body stress, particularly arms, shoulders, and wrists due to all the repetitive motions. The semicircular pattern is proven to be the best biomechanical pattern. Wheelchair propulsion is going to be affected by how the wheelchair sits, the seat height, the seat angle, the position of the drive wheel, if it's anterior, posterior, and the size of the wheel. So the goal is always going to be to reduce excess movement and conserve energy to prevent injury, and then while maintaining performance and efficiency. So seating, this is obvious for all wheelchairs, but you want a firm, snug, efficient base of support that maximizes balance. And these athletes, they're moving around. There's a lot of force involved, and padding is usually a minimum because you want the athlete in wheelchair to almost function as one specific unit. So that's why, a snug fit is extremely important. And they're starting to use like 3D modeling or 3D printing to actually mold the wheelchair specifically to the athlete. Seat height, obviously, it affects the position of the elbows and shoulders, which is going to affect efficiency and also the risk of injury, which I'll talk about in a little bit. And then backrest is another thing. A higher backrest is more stable, but reduces movement of the trunk. Lower backrests are less stable, but they require the athlete has more trunk strength and endurance. So, with backrest, you need to factor in level of impairment and their ability to control the trunk. This is a study from 2009 about seat height, and it was 12 people with spinal cord injury. 8 of them were incomplete, and they tested 8 seat heights. Basically, tested it based off their elbow angle. So they had a range of elbow extension from 70 degrees to 140. Full extension would be 180, so just for reference, but 70 to 140. And basically, the study found that physical strain and mechanical efficiency were significantly affected by seat height, with the optimal values of mechanical efficiency at an elbow angle of 100 to 130 degrees. Lower seat heights were clearly detrimental to efficiency and physical strain. This is a study from 2012 about backrest height, and participants were they basically propelled on a motor-driven treadmill on level ground and at a slope of 3 degrees at constant speed. And basically pushing with a low backrest height enabled significantly greater range of shoulder motion, increased stroke angle, increased push time, and reduced cadence in the wheelchair. So a low backrest height, if the athlete can tolerate it, is likely better and more efficient for performance. Camber angle is something I think probably everyone's familiar with. Standard wheelchairs usually have about 2 to 8 degrees. Sport or adaptive wheelchairs have about 15 to 20 degrees. And, this is something that I wondered about watching the Paralympics this past year, is why the camber was so wide. And basically, it, as we all know, it creates a wider wheelbase, improves lateral stability, turning and maneuverability. It actually increases speed, and it provides greater hand protection from collision in sports like wheelchair, rugby, and basketball, where you're kind of banging, the wheelchairs are banging against each other. There are some downsides, to increasing the camber. It shifts the center of gravity, and it leads to an increased tipping risk. You can have more issues negotiating smaller gaps, and it reduces the contact of the tire with the floor because of the angle, and it can make it harder to accelerate or brake. This is a study from 2012 that I was looking at, the effects of rear wheel camber on maximal effort mobility performance. And basically they tested camber from 15, 18, 20, and 24. And the best camber angle based off all the studies they did was basically 18 degrees of camber was found to be the best performing for both linear and non-linear aspects of mobility. It's like, my question was, why would that, increasing camber increases speed and acceleration, but why would 24 be worse? And one thing this study and other, sources I was looking at, there may be increased linear drag from having a wider base. And there may be there's less contact of the wheels with the ground at such a significant high camber angle that may be what causes the decreased sprint times and acceleration. So there is kind of like a sweet spot for camber angle. Wheel position, as we know, wheels closer to the body, allow the arms closer to the body with bent elbows and leaning forward during the propulsion phase, which is all more efficient for movements and injury prevention. You want to obviously keep your arms tucked and keep it as physiological as possible with the elbow extension and, shoulder flexion. The axle location, just like the vertical line of the midline, or the vertical line of kind of I'm blanking on the word, of center of gravity extending downward, is usually preferred. It should be just forward of the vertical line of the center of gravity. Really, for sport wheelchairs, they think it should be on the brink of tipping with all 4 wheels on the ground for maximum efficiency. It allows the arms to grab a larger portion of the push rim to increase the stroke angle. It balances more of the weight on the larger wheels. It reduces downhill turning of the chair. However, a downside is it does decrease stability, as we know, and you may need to add anti-tippers, if you have it too far forward, if you have the wheels too far forward, and adding anti-tippers adds weight, which can also decrease performance. So it's you want to find that sweet spot there. Wheel size, most wheelchair athletes use 24 to 26-inch wheels, depending on the sport, but that's the average, and 3 to 4-inch caster wheels in the front. In general, smaller wheels are easier to accelerate, but larger wheels have higher top speeds and less power requirement over time due to torque, which I'll talk about in a little bit. And you have to obviously factor in the size of the athlete. Athletes with a lower stature or less upper extremity strength will benefit from smaller wheels, just because it's easier to get it started and get the wheel started. And larger wheels are generally preferred if possible, as there's less fatigue over time and a lower injury risk. This is another study. This Mason guy keeps busy in this field, but in 2012, the effect of wheel size on mobility performance in wheelchair athletes, and they basically tested, 3 separate sizes of wheels, which equated about 23 inches, 24 inches, and 25.5 inches. And the larger wheels improved maximal sprinting performance of highly trained wheelchair basketball players without any negative effects on acceleration or maneuverability. So the improvements in sprinting were thought due to a combination of reduced drag forces and improvements in coupling due to the lower angular velocities of the wheel hand rim in larger wheels. So it's a technical way of putting it, but the larger wheels were felt to be more efficient and easier to propel over time. The push rim, the size of the push rim can vary, particularly in which we'll talk about in wheelchair racing, it tends to be smaller. And then in sports like rugby or basketball, where it's more a long-term fatigable type of sport, the push rims are bigger. So torque is a radius over distance, radius times force. So a larger push rim has a larger radius, so you can generate more torque with less force. So it's easier to get the larger push rim started. Whereas smaller push rim, you need more force to generate the same amount of torque. However, once you're able to generate that torque, the amount of times that if you can generate that force to start, if you can generate the force for that level of torque, you can start accelerating a lot faster, because as every time you rotate the smaller push rim, the larger wheel rotates. And I was having a hard time understanding this, or kind of conceptualizing this. It's kind of similar to gears on a bike. If you ever rode a gear bike, when you're in lower gear, which is like a smaller push rim, it's harder to get started. But once you start pedaling, you move a lot faster than a larger push rim would be when you're in higher gear. And you can pedal much easier, but it takes a lot more cycles to keep your speed up and move. You're pedaling really hard, which is why it would make sense, if you want just pure acceleration and speed, you'd have smaller push rims. So this is just, there's a ton of wheelchair sports. This is just a quick overview of different types of sport adaptive wheelchairs. Basketball wheelchair design, you need easy maneuverability, but you also want to minimize fatigue over the course of a long game to maintain performance and prevent injury. So there's 6 wheels typically, 2 large drive wheels, 2 swivel casters in the front, and 2 swivel casters in the rear to prevent tipping. Large drive wheels are close to the center of gravity, as we talked about. They're easy to turn and easy to efficient propulsion. The camber is usually 15 to 22 degrees. Seat height varies by level of injury, but in wheelchair basketball, seat height, there is a max seat height, because just like real basketball, being higher up helps you shoot over the opponent. So they do have max seat heights. And basketball wheelchairs tend to have larger push rims because it's easier start and stop of the wheelchair, and it limits fatigue over a long game. And the footrests tend to be tucked under the seat to reduce angular momentum, keep the center of gravity more compact, and allow you to turn quicker. And there is position-specific wheelchair designs. The guards tend to sit lower with a lower center of gravity that improves maneuverability and turning, whereas the forwards and centers sit higher to get closer to the basket. Tennis wheelchairs are pretty similar to basketball wheelchairs, but they require quick change of direction, maneuverability, and they're built for endurance. They have large wheels, large push rims, cambered wheels similar to a basketball wheel. But since there's no contact in wheelchair, tennis wheelchairs. There may just be one single and single front and single rear caster. These pictures I realize have two, but there tends to be less. They can make the just one wheel or smaller front wheels because there's not as much contact and you don't need as much stability from collisions. Rugby wheelchairs are kind of cool looking. They're designed for high speed and high impact. They also have, larger wheels with large push rims. There's 6 wheels. The drive wheels are near the center of mass, and you have small caster wheels, and you have safety wheels in the back because it is such a high impact sport. There's a large posterior seat angle in these because the athlete, when they're playing rugby, they hold the ball kind of in their lap as they're pedaling. So you need that large seat angle to be able to hold the ball as you're using the wheelchair. And then you see those solid wheelchair covers are commonly used to protect the spokes and to deflect other chairs. And there are two different types of chairs in wheelchair rugby. The offensive chair is the one on top. It's a lower profile with that front bumper and the metal wings to try to make it harder to stop and stop defenders from being able to stop, prevent them from moving forward. And the defensive wheelchairs on the bottom, it usually has that extended front bumper that's intended to capture the chairs or disrupt the path of the offensive players. Racing wheelchairs, I think we've probably seen these plenty of times. There's 3 wheels. You use 3 wheels because only having 3 wheels reduces rolling resistance and makes steering more efficient. So that's become basically the standard of design in racing wheelchairs, which it really hadn't been until the 1990s. You want them to be extremely lightweight, obviously, which we talked about a little earlier, but the lighter it is, the faster you can go. The front wheel is usually 20 inches in diameter. The back wheels are usually 25 to 27. It's a T-frame design. Is the most common, where like the one frontal tube going to the front connects the axle of the rear wheels, and another tube is welded at a 90-degree angle. The steering gear mounts between the forward pointing frame tube and a spring-loaded crown compensator, they call it. That's the way the athlete turns. You could kind of see it in that bottom picture, but it's a spring-loaded mechanism that they kind of can turn to turn with a steering lever to turn the wheel. The athlete's usually in the kneeling position, leaning forward with the chest really close to the knees so they can have a lot of forward angular momentum when they're pushing on the push rims. And then I talked about this already, but they tend to be smaller push rims in racing wheelchairs because they're harder to get started because of torque. But once you get started, every time you do one cycle of the push rims, it's moving the wheel a whole cycle. So it's easier to accelerate and maintain, or easier to accelerate for short distances and keep top speeds for short distances. So the plans for now and the future, there's a few labs opening up around the world, really. There's smart technology to track performance methods, real-time feedback, or adjust the wheelchair setting in real time. There's some dedicated wheelchair sports performance labs. The one Wheel Power in the Netherlands. That's actually where a lot of these studies were done by Dutch scientists, or I don't know if they're physiatrists or PhDs, but this is where a lot of the studies are coming out of. And the objective is to improve internal, external power output of athletes in their sport-specific wheelchair to perform better in competition. So they're really leading the way in this wheelchair sports performance labs. There are some other ones that I was looking at in the U.S. The Kelly Adaptive Sports Research Institute's associated with Spalding in Boston. There's the Mobility and Adaptive Sports Research Lab in Montreal, Canada, and there's many more throughout the country that are popping up as wheelchair athletics becomes more and more popular and more and more prestigious. So in conclusion, wheelchair configuration and performance is an active, ongoing field of research. Just like other sports just like other sports like golf and F1 racing and tennis, every small advantage and every inch, every second that can be gained with the wheelchair modifications is going to matter and can make the difference between gold medal, silver medal, or not placing at all. It's not a one-size-fits-all. You need to consider the athlete, the impairment level, the sport, and the position being played. So every athlete, especially at the highest levels, make sure their wheelchair is configured exactly to what they need. And, for all of us, even if you're not involved in sports wheelchairs, a lot of the innovations that are found in wheelchair sports are being passed down to everyday use wheelchairs. and it's important for the PM&R physician and therapists and everyone to have a basic understanding of these wheelchair modifications because they're going to affect our patients on a day-to-day basis as well. And those are my references. Any questions?
Thanks, John. That was excellent. I learned a lot. Let's open it up, to the floor for questions. I have a few, but we'll see if anybody else does first. John, just leave the PowerPoint up.
Oh, okay.
Any questions from anyone? Okay, I'll go in if other people have questions. So how much do these wheelchairs cost?
That's a great question. That's a really good question. I actually didn't even think about that, to be quite honest. That's a really good question. I don't know.
Yeah, I mean, I think obviously, Diana, please feel free to weigh in because you're probably the number one expert here.
They are uncoated items. So in the world of wheelchairs, that means they are not reimbursable by insurance. So they're mostly an out-of-pocket expense. They can range from $1,000 to $10,000, depending on how the materials usually is the manufacturer, how specified you want to get them. Most people trial them in use first in the sport that they're involved in, and then they kind of learn their own customizations and purchase them usually online or right from Top End is one of the biggest manufacturers that make this type of equipment. So they're purchasing either from Top End themselves or a company like spinlife.com.
Yeah, and I've heard that before where players a lot of the time will lend equipment from other members of the team and they can try it first, before buying something. John, do you know when and this is again, I just don't know this, and Diana may, when do they become, very sports specific? Is there like a general like high school athlete chair that is very adaptable for like, tennis and basketball and, a few other sports, or like, does it get to be pretty sports specific pretty quickly?
I guess that's a really good question. I guess I don't know exactly when that process starts. I realized I was kind of focusing on the end game, which is when they're already like Paralympic athletes, but I don't know exactly when that transition happens. That's something I could look into that though.
From what I understand, and I don't know the end all be all, but they join a league. It used to be over at the Carousel House, was a really big one in our area, and that closed a little bit pre-pandemic. And there's a lot of leagues that are now out of West Deptford at Riverwinds with wheelchair basketball and wheelchair rugby. McGee has a huge especially I think this year is one of their best years, as I hear, in wheelchair rugby. So they kind of join the league. The league has chairs, and they get an understanding of the wheelchairs through these leagues that they join. The higher level ends, then you probably have more equipment. I don't know all the ins and outs of it, but that's kind of the basics.
And then again,
I don't know if I'm gonna know the answer. All right.
But there's Diana's here too. When how like the highest level, how specific are the regulations? Are they like now very like, because there's always more and more technology. Like, are they when you think of like high end NASCAR racing, they're like, this is how much you can have the fenders be size wise? Are there a lot of limitations when you get to the highest level in terms of like how specific they have to be with the wheelchair?
Yeah, I tried to look. That wasn't as easy to find. I actually did look into that, and I just couldn't find like anything specific other than saying like I think that there's limits on the wheel size in wheelchair basketball. I saw, and like the seat height, obviously, because that's a big advantage. But I couldn't find any. I was trying to look on the Paralympic site and stuff, and there wasn't anything like a set rule or anything of that. I'm sure it's in there somewhere, but it wasn't. I know that's not a good answer, but it wasn't like easily accessible, like obvious, at least when I was looking through.
Mm-hmm.
Because I was wondering the same thing, actually, but I couldn't find anything obvious on that. I don't know. Yeah. That's good.
And I have two more questions. Where do you see like the future going? What are the trends? Like what do you think is
Yeah,
next?
I guess I think the trends are just number one, the materials keep getting better from what I was reading. I mean, they're taking this stuff directly from the aerospace field, so they're just continuing to use lighter, faster, stronger materials. I think they're really, almost like from what like when you get like your golf clubs fitted, like your swing fit and like almost a wheelchair version, like they're having these athletes tested in specific labs to see like what their backrest height, like what their best backrest height is, what their best camber angle is, what their best seat height is. So, I mean, it seems like they've been doing that, but it seems like from what I was reading, it's getting even more specialized in the exact specifications of each athlete and what's best for them, which was pretty interesting.
And I guess I'll make this more of a comment, get you off the hook a little bit, John. But another interesting area that maybe somebody else in the future would want to present on is power wheelchair sports. I don't know if you came across anything on that topic or.
I did a little bit, but I didn't. This was already probably like a little. I mean, this is probably already like a little over 15 minutes, so I didn't like dig into that too. But I did see a little bit about that, but I really didn't. I didn't dig into it too much, honestly.
Yep. All right, Diane, any other comments?
No, that was an excellent presentation. I learned some. It's hard to keep up on all the literature, so I think you did a great job of looking through the literature and really relating it back to the history of more sports-specific wheelchairs. Great job.
And then my last comment would be, getting involved in these sports can really be life-changing from like the peer mentorship perspective, confidence, physical health. So, it's something to always keep in mind. And I'd be surprised if there's not some scholarships out there that can help, provide for some of this equipment. But with that, I will end today's in-service. Thanks again, Dr. Lasko. This lecture, like all the rest, will be available on the YouTube page. So feel free to review it again at your leisure. Thanks.